Hello. It's been a while since we had one of these streams. I think most people have forgotten about them. Well, that's not true. We had a presentation just recently, but it's been a while since we had a lecture style one. So here we go. Before I start, you don't have a task for today except to work on your final finished product, but you do need to fill out those course evaluations when you get the chance. Please give us thoughtful and insightful comments. We're really thinking a lot about how we're going to do this course in the future, and we want to know what you thought about how it was done this time around. I guarantee you that I'm going to read every comment. In fact, I will show you me reading every comment because I will live stream me reading all of the evaluations sometime the week after they go live. So they usually go live a few days after the final grades post a banner. And obviously they're all anonymous and everything. Thank you to whoever liked my glasses. You're the real MVP. Just put that in the reviews as well. Oh no, that's Jared. He doesn't get to fill out an evaluation, so darn. Well, okay, you get to put it in the review too. But really, give us your thoughtful and insightful feedback. Let us know what you liked. What you didn't like was going through software engineering hell or not. Was that fun or was that not fun? What would you have preferred to do instead? What parts did you like? What parts did you not like? What do you feel like you got out of it? And I know it's a lot to ask too, but I really appreciate when people come back to me in a year or two or three or four when they're in industry or when they've had an internship or whatever. I really appreciate when people come back and tell me what parts of their job ended up being a lot like working for Company Co. and what parts did not. So if you remember me, if you remember this class, please feel free to reach out after you get your first real job and you've been there for a bit and let me know what parts felt like it. Even if you're working now, I get a lot of people who have already had internships or something in those class now telling the other people in class, it was a lot like this at my work. And, those kinds of things are always very helpful too. Because at the end of the day, we're trying to make the industry a better place. A lot of the things that I've simulated for you are definitely the worst case, and I hope that you never experience those. I hope you don't work for companies that are like them. But you might, I don't know. And I'd like to hear what aspects of your job in the future are like what you experienced here. So, yeah, definitely reach out to me. Let me know how your actual jobs or internships pan out. Tell me if there's a Mr. Steve or a Chad Chadwick at your work. All of the characters that I play in this little drama that I've put on for you are based on real people or amalgams of real people for the most part. I usually take the worst of several different people that I don't like and put them together for some of the more negative characters and the best of some others and put those together. The most realistic person is probably the customer. The customer. That's probably the most realistic character of them all. So I almost guarantee that all of you will work with a customer similar to Company Co. in terms of the demands that they impose on you at some point. Hopefully not in terms of the amount of amorality that they indulge in, but definitely in terms of the demands that they put on you. And one of the biggest differences, I think, and people like to point this out very much, the difference between this little drama we've put on and the real world is in the real world, it's a job, you get paid, you continuously show up to it. I mean, obviously there are contract positions that are timed, and so one of the best parts about 270 is that it ends next Friday, basically, right? Really on Monday after the exam. It's over and you're free, and it doesn't matter what happened with the project at that point. It's over for you. And there's no overtime and none of that business. But you also don't get paid, so it has its positives and its negatives too. Okay, well anyway, talk too much about that. Let's go into the last lecture on testing, because we did a little bit about testing earlier, and we were talking about system testing and test-driven development and all those fun things. So hopefully you remember those, because those will definitely be on the final. But let's talk about a few more things about testing that might also be on the final, or might not be. You never know. So we talked about system testing last time around. We talked about developing tests for the entire program, all the different modules working together or groups of modules working together. There's another kind of testing that's not mentioned as much in the Somerville slides here, but it will appear in the book, and that's integration testing. And it's kind of a pass to it here where they talk about system testing during development involves integrating components. Well, some people like to split that off into its own category. So integration testing being basically a subset of system testing. And if you haven't noticed so far, integration is the hardest part, and that's why I kind of put off talking about this too much until now. So as you went through your implementation phase, most of you had a process where you had different tasks and then you came together and integrated them. And almost all the teams that had that approach where Susie does A and Bobby does B and then they come together and combine A and B to make a system, they put off the combining part until like the last day, right? And then it failed utterly, or there were serious issues with putting it together. A couple teams did continuous integration. They were constantly putting things together. And that is the modern and agile way. In fact, we have this terminology you'll see a lot, the continuous integration, continuous development pipeline, referring to our ability to constantly combine code from different sources together, test it to verify it's still functioning, and push it to production. This is the hardest part to do, and this is what many organizations are really focused on out there in the real world. Getting their continuous integration pipeline working, getting their testing robust enough that when somebody pushes a change, we can verify that it's still functional. These are really important things, and integration testing, the combining of different parts together, is probably the hardest part of the whole process. System integration is probably the hardest part of the whole process, and integration testing is probably the hardest part of testing. As many of you realize, that many of you found it so difficult that you just didn't integrate your work at all and just ended up having a couple separate modules. In fact, I think a couple teams even have multiple different main methods reflecting the work of different developers. So not an uncommon way for it to turn out, but definitely unfortunate when you're trying to build one finished product. Let's talk about reuse, right? So a lot of you at least attempted to use existing libraries, testing reusable components that have been separately developed. This is always the way to go when it's a possibility, if it's economically feasible, if it's technologically feasible. Obviously, you don't want to get dependent on too many different external libraries or things that come from other programs, but reuse is much easier than remaking. And testing different components that have been reused also requires integration testing. So when you bring in a library to talk to your SQL server, for example, you also need to verify that bringing it in doesn't create any new issues and that it combines well with your program. Now, you probably won't unit test that library. You'll probably take for granted that it functions the way it's intended. Hopefully they tested it on their end. But you'll definitely have to perform integration testing to verify it slots into your system correctly. So this is probably the more common testing as well, because it is much more common to grab something that already exists and to write it completely from scratch. So you'll see integration testing more than unit testing too, because it's more common to grab something than remake it. Use case testing is developing our tests based on use cases. So this harkens back to the UML use case diagram. And then we can also do the same for a sequence diagram. So let's say we have a sequence diagram like this. We note that part of the functionality is that the user can issue a request, or a report, I guess it takes as an argument, and then we get an acknowledgement back. This creates implicitly a test that we need to satisfy. And this is something that you want to consider if you're going for the adding testing approach. Somebody asked, what's a library? So when you import something into, let's say, your Eclipse that didn't ship with Java, so let's say you had to import in the SQL group, the database group, they had to import JDBC. The demo sensor group, they had to import cperf or whatever the integrated web browser is. They had to import things that were beyond the standard library. Those are projects that somebody else has completed that provide features that they needed. So those are what I mean by libraries, essentially. I'm talking about outside packages. And Hopefully that answers your question. All right, so a implicit test here, I want you to think the same thing when you're going through your requirements. I want you to look through your requirements, look through your diagrams. Hopefully you still have some. I know a lot of UML diagramming broke down over the many generations of requirements, but look at your requirements and see which ones correspond to tests that you can issue. This is one great example of request and acknowledgement. Okay, so an input of a request for a report should have an associated acknowledgement with it. The report should be returned from the request. Somehow it ends up in the user's hands, so that probably implies some kind of user interface functionality there to let you know that there was an acknowledgement. So, I don't know, a pop-up that says okay or something, who knows. An input request for a report to weather station results in a summarized report being generated. This kind of thing is what I'd like you to see in your validation document if you go the testing route. I'd like to see your requirements being defined as testing. And yes, Ernesto said that UML was dead, but you still have to learn it because it's a rite of passage. Just kidding. While many of you did argue that UML was dead, many of you also argued in favor of some form of diagramming. And I would say that a lack of planning altogether is a pretty foolish perspective. So while it might not necessarily be UML diagrams, you ought to have some form of diagram, and you ought to be able to extract some kind of tests from it. And actually what's described here, extracting tests from the sequence diagram, and then we'll see in a couple slides from the user stories, is still a very reasonable and common approach. Even though formal UML is dead, that's more because it had something like a 350-page manual on how to use it, complete with instructions of what every different kind of arrow means, like 16 different arrow subtypes and grammar and all that, and most people just didn't have time for that, to be honest. The informal, what Ernesto calls the masala diagram, tends to very much live on. The informal, sketchy, I tried to learn UML in college but gave up, as many of you have adopted, continues to be popular through the industry and should still be useful for eliciting your requirements. So, some policies. We got exhaustive testing. Can't do that. No way we're going to ever be able to test everything. Systems are too big. Well, what could we do instead? We could test all system functions accessed through menus, so kind of test everything that comes through the UI. We can test all combinations of functions that we feel are accessible through that menu, but that's very hard to do, combinations. Combinations is rough. Wherever user input is involved, all functions tested with both correct and incorrect input. Well, how do you do that? How do you click the wrong thing, or how do you automate that? That's a very difficult thing to do as well. We talked already about test-driven development, so we're kind of going to skip over these here, because you've been there, you've done that. Now let's talk a little bit more about that CICD pipeline. Code coverage. Every code segment you write has to have at least one associated test, so all code written has at least one test. That was a benefit of test-driven development, right? Because you wrote the tests in advance, that means you couldn't have written any code unless there was a test there. And that's one of the strengths of test-driven development, is it forces you to write tests, because you're not allowed to write the code until you've written the test, so you must write the tests. You could also just be disciplined and write the tests in the first place, or in the aftermath too, sorry, not in the first place. So I would encourage you still to follow that test-driven development philosophy and try to write at least one good test, or at least one suite of tests for every code segment that you have, if you're going the testing route. Now, in practice, you've finished the code, you've delivered it at the end of the sprint. Do you actually get time to complete the testing? Not always, right? Documentation and testing are the first casualties of crunch time. And then regression testing. A regression test suite is developed incrementally as a program is developed. We'll skip over the other two and look more at regression testing. Regression testing is testing the system to check that changes have not broken it. So again, that CICD pipeline. Every time you push a change, you don't want to have to manually test everything again. Regression testing allows you to run an automated test every time a change is pushed and make sure that all the tests return correctly. So one of the best approaches to completing this kind of testing for large systems, and something that I hope that all of you adopt for your testing process in these last few days, is something called black box testing, which is addressed on a different set of slides that I'm not going to pull up because just a couple slides here. But black box testing is simply treating your entire system as a black box. Hopefully you've heard that expression before, but That means that you don't look at the internals of the system at all. It's a mystery. It's a mystery box. And inputs go in and outputs come out of it. And that's all you need to know. And so all you need to know is that the inputs that you give it generate the correct outputs. And that's black box testing in a nutshell. Now, that's really hard to do with a user interface involved again. So a lot of the time, you will treat just the non-UI part of the system as the black box. So you'll set up the model and the controller or whatever it is that you've designated in your system architecture as kind of the internals and the meat of the system, and you'll run your black box tests on those. And you just don't change the user interface as much, or anytime you change the user interface, you do manually test it, or you pay for one of the many relatively available user interface testing suites that there are out there. But automated testing of your system as a black box, so just providing inputs to the entire system and then reading the outputs and verifying that they are correct, are very important. Now, this process does require you occasionally to make sort of an extra driver, an extra link, kind of the UI-less or console version of your system might be necessary to complete this kind of testing. So that's often a good idea to have that kind of thing, this sort of test variant, the no user automated variant of your system. Nice to have one of those. Okay, release testing. So let's say you're done. Woo! Well, you were on, what was that, last Friday or whatever, you turned in the project, Monday. After your presentations, you were done. Hooray! Release testing is the process of testing a particular release of a system. Well, I guess you're not done, but you did release a version of it. The primary goal of release testing is to convince the supplier that it's good enough for use. So basically, our validation testing, again, to verify that we've completed the requirements and it's good enough for the customer to use it. Not just validation, verification too, because good enough also includes the ability for it to run on the customer's system without crashing, and generally being good enough from a performance perspective too. Release testing is usually black box because you don't care about the internals. You only care about the inputs, especially the ones that the user supplies, and the outputs, that is what the software generates. So this is generally a black box testing process where the tests are derived from the requirements again. Release testing is technically a subset of system testing. An important distinction that Somerville makes here is unimportant, but he says that it should be a separate team. That's obviously not going to be the case for you. It's testing by the development team. It should focus on discovering bugs in the system. Objective of release testing is test that the system is good enough for you. That is going to be the same, but in practice, it is true that by the time you have finished the system, you want another team to verify that it's good enough for release, because developers can obviously be very biased on the way their inputs are structured and everything, and this kind of leads to the creation of, in many cases, those quality assurance teams, and we'll see the kind of quality assurance document that tells them, okay, these are all of the things that we expect users to do, and then this is all of the stuff that you should do to the system, and then verify that you get these outputs. So you tend to get into that environment with dedicated quality assurance teams if you follow this kind of guidance. Requirements-based testing we've already talked about quite a bit, so testing each requirement, developing a test for it. That's basically what I was looking for in previous generations when you made the validation document. I asked you to pair everything in the validation document to the requirements. I asked you to go through all the requirements and generate that validation document in response. They give you an example from the MentCare system here. They give you an example where he pulls from a user story or a scenario and pulls requirements out of there. So if your requirements are written in an agile way, you might not have any dedicated requirements. Remember, that's the thing now. We don't even have a little bullet list or anything. We just have a bunch of user stories, and we have to make sure that we can fulfill all these user stories, because UML and planning are overrated. We're just going to write a bunch of stories, and that's going to be it. Well, if that's all you've got, you've still got to work with it and make your validation document out of this bunch of stories, right? And so a couple examples here on how you might do that, and kind of what Somerville was able to extract for his validation. You're also going to test performance, possibly. It might be a path that you opt to take, although testing performance is usually a contrived thing to do, and you have different systems and remote, so I assume most of you probably won't opt for this path. And then we have user testing, which many of you are probably already familiar with, the stage in the testing process in which users or customers provide input. So we have alpha testing, like the release of Cyberpunk 2077. That's a good one. But no, seriously, we have alpha testing where a group, usually of the development team or the quality assurance team, look it over. A beta usually goes to the user and allows the user to do some experimentation, but with the understanding that it's going to be significantly flawed. And then in the last step, we usually have our acceptance testing. All of you probably know how uncommon it is for these phases to actually complete in modern day software. Typically, software is released today in an alpha or beta state and then patched to completion in response to user feedback. So these are kind of, unfortunately, old school. All right, that's all I got for you today. Don't forget to fill out your evaluations. Your free finished product is going to be due probably on Friday. I might ask you to do a little presentation on it again. I might not. I haven't decided. So let me know if you want to show off what you've got today when I come visit you in Discord. And don't forget that your minor project presentation is due on Wednesday as well. And then your peer reviews for it, that is, you have to watch 5 other people's, and that's going to be due on Friday. Make sure that you leave people good, constructive feedback on their presentations. Tell them if it was interesting. Tell them if you liked it. Tell them if they were monotone. Tell them what they could have done better. Presenting is very difficult for a lot of people, and you're not going to get better without feedback. So while I'm not going to be super critical about your actual presentations, I will be super critical about you being critical about other people's presentations. So if you just leave like, hey, nice job, I'm going to give you a 0 on the peer review part. You got to actually tell people how they can get better, because that's important. Okay, see you guys in Discord.